Today, we are going to solve problem number 796 from the LeetCode, that is, rotate the string. This is an easy problem, and LeetCode has also marked this problem easy. But there are multiple nuances to it, and I can assure you there are a lot of things that you can learn from this problem. We will solve this problem in 4 steps. First, we will understand the problem, that is, what the problem is asking us to do. Second, we will build the intuition for the problem, that is, how should we approach towards the solution. At the third step, we will actually solve the problem and come up with a solution. At the third step, we will see if our solution can be further optimized to get a better solution. For this specific problem, I will show you 3 approaches to solve this, each approach with its pros and cons. Now let us jump to the solution. So first of all, let's understand what the problem is asking us to do. It says we are given 2 strings. One is S. Let's say S is A, B, C, D, E. And you will be given another string. Let's say this string is called goal. Goal in my case happens to be C, D, E, A, B. The problem is if S can be rotated to form goal. To solve this, first of all, let us understand what do we mean by rotating S. Let's say you have some string A, B, C, D, E. When you rotate it, what you do is you move every character of the string to left or right. Let's say we are doing a left rotation. What that would mean is, say the indexes of this were something like this. A was at 0 index, B was at index 1, then 2, then 3, and then 4. So after rotation, what we do is we move every character to its previous index. That is, B will be moved to the 0th index, C will be moved to the first index, D will be moved to the second index, and E will be moved to the third index. And now if you see, the fourth index here is vacant now. There is nothing here. What we'll do is this A will move to the fourth index now. And the resulting string would be B, C, D, E, A. If we have to perform one more rotation on top of it, if you observe this carefully, you will see all the other characters remain essentially same. Just one leftmost character moves to the rightmost side. So A is moved here. Now if I have to rotate it one more time, the solution would be all the characters C, D, E, A will be exactly replaced in the second time. That is, first of all I'll write C, D, E, A, and then B will move to the rightmost part, and then it will be followed by B. And if you see, this is the target string that I was looking to find. That is our goal. Since we can achieve this, it implies the result is true over here. So you have to return either true or false. In the second example, you have string S that is equal to A, B, C, D, E, and you have another string goal that is equal to A, B, C, E, D. Now you can try rotating A, B, C, D, E to form A, B, C, E, D, and you will realize that there is no way possible you can do this. So in this case, answer happens to be the false. Now the question is, how do we do this thing programmatically over here? So now let us try to build the intuition of it. One thing is for sure that we know till now, that we need to rotate the string and check if it is coming to be the goal or not. So why not just do this? What we'll do is we will have an input string, let's say A, B, C, D, E in our case, and we have to change it to a goal string. We will rotate the input string unless we reach the goal string. Now the only problem is how many times to rotate. You have to see how many characters are there in the input string. If this one has 5 characters here. That means there is no point of rotating the string more than 5 times, isn't it? What that means is if I rotate S 5 times, I should get goal. Simple enough. We'll rotate it once to form this. In the second iteration, we'll rotate it again to form our resulting string. If we cannot find it in the second one, we'll go for the third one and then we'll go for the fourth one as well. And how long we will keep on rotating this? We will rotate this exactly the number of times that is the length of the string S. Because if I rotate it more than the length of the string, I will essentially be doing the same thing again. So let's try to write the code for this first. Let's say my method name is rotate string. This is a fairly simple code to write. This will get two parameters. One is S and another is goal. So as we said, we have to rotate it for I in range of length of S. For every of this iteration, I say S is equal to S plus S of 0. I'm doing this exactly as I discussed. With every rotation, what we do is entire string remains the same starting from the index 1 and at the end of it we add the 0th index value. So in every iteration we are rotating this value. Now every time we perform this rotation we will check if S is equal to the goal. We will just return true at that point in time. If this is not done, we will do return false. Once we have rotated the number of times we want and we do not see this happening, we will just return false. Now let's just add one more condition to it. Before we even go to this part of the code here, we can actually do a sanity check. That would be if the length of the S and goal are equal or not. Because if these two lengths do not happen to be same, there is no point of comparing. No matter how many times I rotate my S, it will never reach the goal. So what I'll do is if length of S is not equal to length of goal, I will just return false. So what I know is if the length is not equal, I can straight away return false. I don't need to do any calculation. Now this code here definitely works. Okay, no issues with this. There is just one problem. We have to see how complex the solution is. To analyze the complexity, let's see what we're exactly doing. This is one part where complexity is derived from. Here we are doing n iterations. Okay, so this gives me a complexity of n. And here we are rotating the string every time. And every rotation, n per rotation. For every rotation, I'm using n cycles. Because every character needs to be moved to left and then the leftmost character needs to be moved to the right part section. That is, the total complexity that I have here is O of n square. This is something that we would not want. In our case, n is equal to 100, but assume if n is equal to 1000, now the complexity can easily become 1000 square. And as and when you start increasing the number of n, this complexity will start growing. Now there is another solution to this. Next solution is fairly simple, easier to write, and with lesser complexity. I'm defining a method, a rotate string. This method will again take two parameters. One is S and another is goal. To solve this one now, we will use a very simple trick. Please pay attention here. Let's say the input string that I have is, again, I'll take the same example, A, B, C, D, E. And the goal to be achieved is C, D, E, A, B. Now, the trick here is to make the input string S of double the size. We'll double the size by doing S is equal to S plus S, which is equal to A, B, C, D, E, A, B, C, D, E. Now, if you look at it closely, I have removed the rotation factor from the S because I have added the same thing on top of it. What this means is now your goal string should be directly a substring of S. If you look at it here, C, D, E, A, B is something that we are looking for, and you can find it here. Whichever string it is, if you concatenate S over itself, then goal should be substring of it. If goal has to be obtained by rotating S. Let's see another example also, which was S is equal to A, B, C, D, E, and goal is equal to A, B, C, E, D. A, B, C, E, D. Now let's do the same thing again. S becomes A, B, C, D, E, A, B, C, D, E, and the goal is same. Now try to look for A, B, C, E, D in this one. Do you find it anywhere? If you look at it in this entire doubled string, you will not find A, B, C, E, D. Since you cannot find it, here the result would be false, and here the result would be true. That means the code is reduced to just one line now. What I have to find is if goal in S plus S, then return true. If this is not the case, then return false. Obviously, before this also we can do the same sanity check that we did last time to check if the lengths are equal or not. But for the sake of explanation of this part, that is not needed over here. Now let's try to understand the complexity of this problem. There are two places from where the complexity might arise. First one, here, this part has a complexity of n because I'm just adding a string on top of the same string. Second part is this one, in operation. Okay. Now this is really tricky one. If you think about it, normally to check if a substring is present in a string or not, the complexity would be n square. That is, if you have to do a naive substring check, writing it here naive, because if we do a very basic check, that is, what you'll need to do is at first index you will check if this a b c d e is equal to a b c e d. Then you'll move to the second index, you'll check if b c d e is equal to a b c e d. Then you'll move to the third index and you'll check if c d e a b is equal to a b c e d. Then you'll move to the fourth index and do the same thing again. So for these 2n characters, you have to check these n characters over here, and the complexity would become 2n square, that is equal to n square complexity. And this entire problem will become a n square complexity problem. But while you are using this in using Python, or if you are using certain algorithm like KMP, you can reduce this complexity here to n. There are ways possible which languages internally use, and this complexity is reduced to n. So overall, the complexity of this problem can be said to as O of 1. But there is a problem here. If you are in an interview, your interviewer might ask you how this complexity becomes n. And then additionally, you would need to explain them how KMP or other algorithms like Boyer-Moore algorithm or some more algorithms are there, how they will reduce the complexity to n. And then you will have to support your solution with your argument. If you can do that, well and good. In this video, at least, we are not going over KMP or any other algorithms. But yes, this is for your understanding that there are ways you can solve this in O of n. Now, let's try to figure out if there is some other way which we can use to get the complexity of O of n only, but without doing this substring check. We happen to have one solution. Let us see what is that. Again, let's jump back to the problem statement. I have one initial string, that is A, B, C, D, E, and I have one goal that I need to achieve, and this is C, D, E, A, B. Now, if you look at it closely, the question is if this S can be rotated to form the goal. Now we know if this is rotated, the sequence of the character should still be the same. That is, this A that is coming here at the 0th index, this A is going at 0, 1, 2, 3, third index. Okay. Now, if I start counting from the 0th index here in S, and if I start counting from the third index here in the goal, okay, then I should get the same string. Let's see. If I start counting from here, the first character is A, and from here, the first character is A. In the S, the second character becomes B, and in the goal string, the second character again becomes B. In the first string, the third character is C. I write it down here. In the goal string, there is no third character, so I bounce back to the starting of the string, and then the third character is C. Here, in the first string, the fourth character is D. Similarly, here, the fourth character is D. Here, the fifth character is E, and in the goal string also, the fifth character happens to be E. Now, we have observed that these two strings are equal. Okay. The only problem is, how do we do this? Essentially, what I need to do is I need to iterate over this string S once. I need to iterate over this string goal once and see if the corresponding characters are equal or not. I will get the required complexity. The only problem is from where to start. In the goal string, I know one thing for sure. Wherever I start in the goal string, the character has to be the 0th character of the string S. Because no matter how many times S is rotated, I will have to start from a position where I get A. Otherwise, I will never get the required string. Isn't it? So the first problem for me is I have to find the positions in my goal string. Find positions of A. That is, I have to find all the indexes where A is present. And then I have to check accordingly. Let's try to write the solution for it. Again, the function name will be define rotate string. This will take two parameters. One is S, another is the goal string. Now first we'll do a sanity check. If length of S is not equal to length of goal, this is the same thing that we did last time, just to have a basic sanity check. So we'll return if the length is not equal. Now first thing, as we discussed, we need to see what are the string positions. So let's say there is a variable that I defined. This is string positions, and this will contain all the positions where the first character is stored in the goal. I, for every character in the goal, will check if character is equal to S of 0 or not. As simple as that. If that happens to be the case, I'll store I. So this string positions here will store all the values of I where character is equal to the 0th character in my S. And this will give me the string positions. Now once we have got all the string positions where my first character can be present, we will start iterating over the initial string and the final string to see if a match is found or not. So the code is again very simple for that. Let's say for start in starting positions, because I want to check for all the starting positions that are there. Initially, I have a variable that is match found, and its value is set to be true. In between, wherever we see this is not matching, we'll just return false. Now here, let me do an inner loop for I in range of length of S, because inner loop we want to iterate over the entire S. Our goal index will be start plus I. Now this I'm doing start plus I because I is the index of my S and start is the starting position. Basically, if my starting position here, if you see, is 3. So when my S is at 0, I have to add 3 on top of it so that my goal can become at 3. But this is not enough. We need to do one more thing. We have to find a modulus on top of it that will be dividing it by length of the goal. We are doing this so that we can rotate our goal string. That is the moment my index starts to go beyond 4. 0, 1, 0, 1, 2, 3, 4. Till 4, it'll come here. But the moment it goes to 5, fifth index is not present. It will start throwing error. So what I do is I just divide it and do a modulus operation by dividing it with 5. Now the result would be 0. That is, when the index becomes 5, it automatically translates to 0, and 0th index is this. Exactly the same behavior that we wanted. Now once I have found goal index and the string index, what I need to do is I need to check if s of I is not equal to goal of goal index. If there is any index where the values are not there, I straight away say match found is equal to false, which was set to true initially. And since I found this, there is no need to continue with the inner loop, and I will break it. If after doing all this operation, that is running through both the loops, I do not found any case where my match found happens to be false, that is if there is no index at which the values are different, I will check it here. If match found, then return true. Or else if nothing happens in the code, I just return false at end of the code. And this again shall give me the same result. Now let's try to run these things in the LeetCode environment and observe the results, how they are working. If you look at it, again, the complexity of this solution would become n only, because now we are not doing any additional operations. We still have two loops. One is the outer loop and another one is the inner loop. But we have to see that in inner loop, we are only iterating from the positions where there is a possibility of finding a match. So again, theoretically, this complexity can be more, but practically if you see this, the complexity will be O of n, adding 1 and 2. Now let's try to run the first code that we had written. In this one, we are rotating the string every time and checking if s is equal to the goal. If there is any case where s is equal to goal, we return true. If I run this part of the code, I see that the results, I pass both the test cases. Let's try to submit this and let's see what happens. As we can see, it is passed. All the test cases are passing. Now let's try to run another solution. As you can see, this one over here is pretty simple and neat to write. What do is I just apply a simple trick where I concatenate the initial string with itself and make it of the double length, and then I check if the goal is present in the doubled string or not. If it is there, that means I have to return true, otherwise I have to just return false. Now this test case are passing here, all the basic test cases. Let's see it for the result as well in the hidden test cases. And again, all of my test cases are passing with the second code as well. Now let us try the third one that we implemented at last. This one, as you can see, it might look a little bit lengthier of the code, but if you try to look at it, every piece of the code you have implemented by yourself and you can control the complexity as you wish. There is nothing like hidden complexities here, and this piece of code will give you more understanding and more control over your piece of code. Especially in the situations where you are appearing for an interview, this might help you create a better impression on the interviewer. Once you have solved it with the two approaches, they might ask you to come up with the third approach as well, and this can definitely come to a rescue then. This has the same complexity as the second one, practical complexity at least. And if you try to submit this as well, This should also pass for all the test cases and the result should be same. So here I have presented you with the 3 solutions to this easy problem on the LeetCode, which teaches you a lot.